last video, we talked about solving linear equations. We're going to do some more examples in this video. Just to remind you, the way that we solve them is using the golden rule of math. And the golden rule of math says we have to do unto one side as we do unto the other. And by that, we mean one side of the equal sign versus the other. And we can use the addition rule or the multiplication rule, which basically is just a continuation of the golden rule. The addition rule says I can add or subtract anything I want to one side as long as I do it to the other. And then I can multiply or divide anything I want on one side as long as I do it on the other. Now, in the last video, we talked about our goal is to isolate our variable. And in those examples, they were quite simple, and it was either the addition rule, the multiplication rule, or some combination of both. In this video, we're going to continue to use those rules, but our equations are going to get slightly more complicated. So for example, in this first one, we see that we have variables on both sides. So now our goal is to isolate our variable, but before we even talk about doing that, we want to pick teams. This is kind of like playing kickball. All right, and so if you've ever played on a team, you might have blue jerseys and red jerseys, and when it's time to line up, all the red jerseys know that they need to go to one side, and all the blue jerseys need to line up on the other. And we're going to do that for our equation. In other words, I want to get all my variables on one side and all my numbers on the other, and it doesn't matter which side as long as you're consistently moving in one direction, okay? So just randomly, I'm going to take this to be my variable side, this to be my number side. And so I want to move all my variables over here and all my numbers over here. In other words, this would be a variable because it has the x. This would be a variable because it has an x. So I want to end up with all of these over here. And this would be a number because it's just a number without a variable, and this would be a number. All right, so first, if this is my variable side, I see how I have this number sitting here, this -7, and I want to move it to the other side. In other words, I want to get rid of the -7. It's offside, so to speak, and we want to make sure it gets back on the right side. So the way that we get rid of this is by adding 7. And again, whatever I do on one side, I have to do on the other. Now remember, I can only combine variables with variables that look exactly the same and numbers with numbers. So I can't put the 7 with the x because they're two different things, but I can combine the 7 with the 10. All right, so when I add 7 each side, notice here -7 plus 7, those will cancel out, and all I'm left with over here is the 5x. On the right-hand side, I'm not going to do anything with my variable because, again, I can't combine these. This does not have a variable. This is combining like terms, and I can only combine terms that look exactly alike. But I can combine a +10 and a +7 would give me 17. And now I'm halfway home because notice now I have no numbers on my variable side. All my numbers are on the right-hand side. The only issue is that I have this variable still hanging out here on the number side. So I want to get rid of that. Or we can think about it as moving it over. And now the way we get rid of a +2x is by subtracting 2x. Just like we do with the number, we're going to add the opposite. If it's +2x, we subtract 2x. And whatever I do on one side, I have to do on the other. Well, since these both have an x, these are like terms, and I can combine them. 5x minus 2x would leave me a 3x. And over here, the 2x minus a 2x cancels out, goes to 0, and I'm just left with the 17. And now this should look like something we solved in the last video. For my last step, I want to get rid of the 3. I want to isolate my variable all by itself. I'm currently multiplying x by 3, so the way I undo that is by divide by 3. Whatever I do on one side, I have to do on the other. On the left-hand side, 3 over 3 goes to 1, so I'm left with 1x. And on the right-hand side, I'm left with 17 over 3. And now when we end up with these fractions, they are legitimate answers. They're a little bit more difficult to check in our answer. But one thing you could do is convert it to its decimal and do a quick check that way. So I'm just going to use my calculator, 17 divided by 3, 5.67, and we could do a quick check by plugging in 5.67 for x here and here, 5 times 5.67 minus 7 gives me 2135 on this side. 2 times 5.67 plus 10 gives me 21.34 on this side. And again, they're just slightly off because I used a decimal and not the exact fraction. So they are the same. Okay. All right. Here we have another example. This is very similar to the first one we did. I'm just going to let this be my variable side now and this my number side, just to show you it doesn't matter which way we go. So first I want to move all my numbers over here. I'm going to add 7. Whatever I do on one side, do the other. So we get 13x plus 9 equals minus 5x, because negative 7, positive 7 goes to 0. Now I'm going to move my variable over here. I'm going to subtract 13x each side. 13x minus 13x goes to 0. I'm just left with the 9. And over here I have negative 5. Negative 13x is going to give me negative 18x. And for my last step, I'm currently multiplying by negative 18. So I'm going to divide each side by negative 18. Over here I'm left with x, and I want to reduce my fraction if I can. I know that 9 over 18 reduces to 1/2, and there's one negative, so I need to make sure that I have it. So that would be my answer. Now there's lots of different ways to solve these. All right, notice I keep talking about variable side, number side. It doesn't matter. I could have just as easily made this my variable side, this my number side. I would have arrived at the same answer. I chose to add 7 first. I could have just as easily subtracted 2 first. I could have just as easily subtracted the 13x first. So there's lots of different ways to solve these. There's more than one way, so please don't get hung up on, oh, I'm doing it wrong. As long as you follow the procedures, do unto one side as you do unto the other, you should arrive at the same answer. All right, let's do a few more examples. In this next example, you'll notice that I have a long list of terms over here and a long list of terms over here. And so what we're going to want to do first in this case is combine our like terms before we start moving those terms back and forth. And that will just save you time. So I'm going to look at each side of the equal sign separately and see what I can combine. I have a 5x and a minus 3x. Again, this is just adding and subtracting. So if I had 5x minus 3x, it would end up being a 2x. I have a negative 4 and a positive 10. So negative 4 plus 10 is a positive 6. And now I'm just going to turn my attention to the right-hand side and combine anything I can. I have a 7x. Well, I have no other terms over here that contain a variable, so I'm going to end up with the 7x. I have a positive 4 and a negative 10. I can combine those to give me a negative 6. Okay, and now we're back to the problems that we just solved. I want to get all my variables on one side, all my numbers on the other. So first I'm going to make this my number side, this my variable side. I'm going to subtract my 2x. This is my number side, so I only want my numbers, so I'm going to get rid of this. The way I get rid of a positive 2x is by subtracting 2x. Whatever I do on one side, I have to do on the other. Here, the positive 2x and the negative 2x cancel out, leave me a 6. 7x minus 2x leaves me a 5x with the negative 6. Now I had declared this my variable side, and I still have this number hanging out here, so I want to get rid of this. The way we get rid of a negative 6 is by adding 6. Whatever I do on one side, I have to do on the other. 6 and 6 is 12, and on the right-hand side, I have the 5x. And now for my last step, remember our goal is to isolate our variable. We're going to divide this by 5, divide this by 5. Over here, the 5 over 5 goes to 1, and I'm left with x. And over here, I'm left with 12 over 5. Okay, and we're done when we have our variable isolated all by itself. All right. Now, sorry, I moved into the next problem. So let's try to ignore the one before. All right, what happens in this case when I have a number in front of the parentheses is I'm going to need to get rid of my parentheses first. The way I get rid of parentheses is by distributing through the number. Now on the left-hand side, I'm going to distribute the 3. And on the right-hand side, if you have a negative sign, remember, don't forget that. The entire thing gets distributed. So on the left-hand side, I have 3 times 2x. That gives me a 6x. 3 times 7, positive 21. On the right-hand side, I have negative 4 times 3x, negative 12x. Negative 4 times a negative 4 is a positive 16. And now we're back to picking sides. We'll make this our variable side, this our number side. I have a number on the variable side, so I want to get rid of it. It's a positive 21, so I'm going to subtract 21. Whatever I do on one side, I have to do on the other. Positive 21, negative 21 goes to 0, leaves me 6x. Over here, I have a minus 12x, positive 16, negative 21 goes to negative 5. And now I declared this my number side. I still have a variable over here, so I want to move it over. I have a negative 12x, so I'm going to move it by adding 12x, or get rid of it by adding 12x. Whatever I do on one side, I have to do on the other. 6x, 12x gives me 18x. Negative 12x, positive 12x cancels out, and I still have the negative 5. For my last step, again, I'm trying to isolate this x. I'm going to divide, because I'm multiplying by 18, I'm going to divide by 18. Some of the hardest things my students tell me is, when do I add and subtract? When do I multiply and divide? And pretty much you notice that we would multiply here to get rid of our parentheses, but we're adding, subtracting here in the middle, and our last step is to multiply or divide. So over here, this goes to 1, so I'm left with 1x equals minus 5 over 18. All right. I have 2 more examples. All right. This example is very similar to the last one. I just wanted to show you that you might have to distribute and combine like terms. So our first step, just like in the last example, is to get rid of our parentheses by distributing the number out front. And now I like to distribute, probably more than the average person, but don't over distribute. Our number only gets distributed to what's in parentheses. This number is not in parentheses, so our number out front will not get distributed to it. Negative 2 times 5x minus 10x. Negative 2 times negative 3, positive 6, and I still have the minus 12. On the right-hand side, 3 times 2x is 6x. 3 times negative 4, negative 12, and I still have the positive 5x. And now what we want to do, just to make our lives easier, before you start moving things back and forth, combine any like terms. I have a minus 10x. Again, we're looking at each side separately. I can't combine that with anything, but I do notice I have a positive 6 and a negative 12. Those can be combined. So on the left-hand side, I keep my minus 10x. Positive 6, negative 12 goes to negative 6. On the right-hand side, I see that I have a 6x and a 5x. Those combine to give me 11x. And I only have a negative 12. Nothing else to combine it with. So we have that. And now we're ready to pick our variable side, our number side. Again, you can do yours the other way. All right, so this is my number side. I want to get rid of my variable. I'm going to add 10x each side. Negative 10x, positive 10x, cancel out, left with negative 6. 11x, 10x gives me 21x, minus my 12. This is my variable side, so when I get rid of my number, it's a negative 12, so I'm going to add 12. Negative 6, positive 12 gives me 6, equals 21x, because the negative and the positive cancel out. And for my last step, I'm currently multiplying x by 21, so to get rid of that, we want to divide by 21. I get that x on the right hand side, because 21 over 21 goes to 1x, and 6 over 21. I notice that I can factor out a 3 from the numerator and denominator, so that's going to leave me 2 over 7. Okay. And now for my last example, dun, 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 I'm going to bring in fractions. And really, they're not that hard if you keep the following in mind. You want to look at all your denominators. Remember that this does have a denominator. It's just 1. And we want to find the least common multiple of our denominators, 3, 6, and 12. In other words, if I wanted to find a common denominator for 3, 6, and 12, what would I pick? Well, I would pick 12. All right, so now once we find our least common multiple, everything gets multiplied by the 12. Now, the key to this being successful is you cannot leave any terms out. So even if you have a term with a denominator of 1, it has to get multiplied by the 12. But notice what's going to happen. If I had 12 over 3, 3 would go to 1, and this would go to 4, right? 12 over 3 is equal to 4. So my first term becomes 4 times negative 2x, so I'm going to have a minus 8x. Here, if I had 12 over 6, 6 goes into 6 once, 6 goes into 12 2. In other words, 12 over 6 reduces to a 2, so I'm left with 2 times 17 in this case, which is 34. On the right-hand side, notice that I'd have 12 over 12, so that's just going to reduce to 1. 1 times 5x would give me a 5x. And this doesn't reduce, but it's over 1, so I don't have to worry about that. 2 times 12 is 24. And notice what's happened. We've ended up with a very simple linear equation that we can solve. So what's the key to fractions? Find the least common multiple of all your denominators and multiply every single term by that least common multiple. Don't leave anybody out, even if the denominator does not need to be cleared out. Now, let's move all our variables to one side. I'm just going to subtract 5x. That's going to give me negative 13x plus 34 equals 24. I'm going to move all my numbers to the other side. Subtract 34. Negative 13x. This goes to 0. This is going to give me negative 10. Divide by negative 13. Divide by negative 13. Anything over itself goes to 1, so I'm left with 1x. We haven't seen this yet. A negative over a negative is going to go to a positive, so this just ends up being 10 over 13, and that can't be reduced. All right, we did several examples, so I hope this helped.